Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to see how to analyze some interesting data set about the coronavirus, right? So coronavirus is it's an epidemic now, so we are trying to see how to analyze it and derive some insight from the available data that we have collected all over the world. So let's see how to work with it. So it is also called COVID-19. So in case you are looking for data set, you can just go with this particular name, right? And then I got the data from several places, from this particular GitHub, from Ramit, and then from Kaggle, right? Some interesting people. So they have done the work for you, so you can just take it and then analyze it for yourself. So let's see some basic stuff you'll be trying to do. So we're trying to answer some of the basic questions, like the number of cases, which country has the highest cases, the top countries affected, distribution per country, cases per day, and several other stuff. So these are some basic stuff you'll be trying to do, right? So let's see how to work with it. So first of all, we're going to import our EDA packages, that is Pandas and then NumPy. Although I don't think we'll be using NumPy. And then we will import our data visualization packages such as Matplotlib and then Seaborn. So we can also use Altair or Plotly, anyhow you want to work with. Then let's import GeoPandas. So we'll be using GeoPandas to help us with our distribution per continent, to be able to map our data set on the continent, right? So that's why I'll be using GeoPandas, and then Descartes is to help us with GeoPandas conversion. Perfect. So now let's see some basic stuff you can do with this. So I'm just going to load our data set. So let's load our data set, and then we will just work on it. So it's going to be df then pd.read _ csv. Then I'll go inside my data folder. Then inside my data folder I have several data sets. So we'll be using our coronavirus data, right, .csv, so that the data set will be working, and now we can actually view it. So if I check it now, let's check it out. It's going to be, wait, I think I made a mistake. Perfect. So let's check the head. If I check for the head, now it's going to come as this, right? Perfect. So this is something very interesting, and then based on how I collected the data, that was how we have it in this particular format, right? So let's try and clean our data set before we move on. So I'm just going to go with my df.columns. If I go with the columns, you can see that it is having a backslash, right, and then new line. So how do we clean this? So let's do some simple data cleaning. We're just going to go with df, right? We are trying to clean all of these things, these new lines. So it's going to be very simple. It's going to be df dot, see what I did, df dot columns dot string dot replace. We are going to be trying to replace these values, right? Remove them out. So we're using regex to r for regex. Then I'm going to pass in the particular stuff I want to replace, which is going to be the backslash n, which is the new line, right? Then I'm going to replace it with empty stuff. Then I'll set regex to be equal to true. So that is how to clean our data set, right? So if I run it right now, you're going to see that it's going to, I made a mistake somewhere, I forgot this, right? If I run it now, see that that's taking off these lines, right? Something very simple. So we can just equate this one to our columns. So it's going to be df.columns, then perfect, right? So we are done with it. So we have been able to get a clean data for our column header, right? Very interesting. So the next thing we'll be trying to do is that we're trying to change these ones. Let's change these ones to make it nicer. So I'll just go with df.rename. Then I'll go with my columns, the column that I want to rename. There are several ways you can do this, but I'll just copy this one here to save us our time. Then I'll change it from this particular format to another format. So let's change it to this format. So this is going to be the format that we are trying to do. We are doing everything from scratch, so there will be a lot of mistakes, of course. Right, so let's go on with this, and then let's try the next one, which is going to be for the next column, for the country and the region. Then we're going to change it to this option, right? You're going to be putting a dash in between it. Perfect. Then I'll set in place is equal to true. So in place is to true. Perfect. Something very basic. So now if I go back and I check it again, the columns, these are all part of EDA. It's going to be clean, right? Perfect. Now let's see the shape of our data set. So this is going to be our shape of data set. It's going to be df.shape, and then we have about 38,000, right? No, 3,850. So this is the data set that we have, 3,885, and then we have 9 columns. Very interesting. Now let's check for the data types. So this is going to be our data types. To see how data is, data types, Then from this, you can see that we have this particular option, right? So we have some index, we have some stuff there. So this index need to go off. So let's check for the first 5 values. So first, see what has first 10 values. Go to df.head 10. Then we have this particular dataset. So this is how our dataset look like. So we have our index column, which we are going to remove off. We have our province, state. We have our country, region, latitude, date, confirmation, depth, and then recovery. So let's make it better. So I just go back to this same thing I did. So df to be df. Then now let's make it like this. Dot columns. I'm going to take off this index because the index is going to waste a lot of time. It's not nice, right? So I just take it off, this particular option, and go with df. Perfect, right? So we have been able to make something out of it. So this is better. Now let's see some other stuff you can also do. So I'm going to be checking for missing value. So it's now dot sum also for our data set. Right, so I'll be checking for the number of missing values that I have within my data set. So if I check for it, it's going to be, so the province has a lot of missing values, but the rest have no missing values, right? Because even for my data sets, even if there is no case, it's registered as 0, right? So that means that it's good. Now let's do a summary. Going to be df.summary or describe. I said that the summary describe. Then it's going to give us a simple description of all the various stuff that we had. Perfect. These are something very basic that we can do. Now let's move on to the other aspect of our analysis. So the first thing is that we'll be trying to see the number of cases, right? We're going to check for the number of cases per date, right? Per date or per day. Because if you look at our data set, if you have it here, you can see that it's having some columns, right? We have some column that looks like date. So we're trying to see how to group everything based on the day, right? So how do we check for the number of cases per day? So it's very simple, and there are several ways you can do that. So we're using the group by. So df.group by. Then I'll pass in my date column. Then I can just pass in the number of confirmed date and all of these things, which we can, for simplicity, I'll just bring the columns up, df.columns, so that I just copy it. So we are just getting for the number of cases per day, right? But so we're using group by. So I just copy this one for the columns. Then I can just paste it here. Perfect. So something very simple. So that is something basic that we can do. So if I run it now like this, I have to actually sum it up. So there are several ways. So if I go with dot sum, is because the diseases are coming day by day. If I go with sum, it's going to be double. It's going to add it over, right? The previous day is going to be adding to it. So the best solution is that we have to use maximum, right? So that is the basic idea. So you can use this particular option, but you can also use the maximum. So let's use the max, and then you see the difference between the sum and then the max. If I go with maximum is going to be a cumulative frequency. So if you check from here, this is going to be 5, 55, 17, 29 on this particular date, right? But if you use the maximum, it's going to give us cumulative, right? So that the previous day, the next day, like it's like that. As you can see, it's very well. So that is something interesting about it, starting from here. So that is something nice, and it's going to add it over based on the cases that are happening. Okay, so that is how to group the number of cases. So you have been able to get one of our questions, the number of cases per day, using the group by. So these are the number of cases per day. That is for confirmed, for death, and for recovery. Perfect. Now let's store that particular data set inside a variable. So let's go to df per day. Then I'll go with the same thing that we have here for the maximum. So store inside the variable that we can use later on, right? So I can have it. So this is the number of stuff per day. So if I go with df per day, now I can just go with the head, and then I can preview the data that I have. Perfect. So let's see some other stuff you can also do. So we'll be trying to check the highest and then the lowest, right? So based on the day, we can use the describe option. So df per day dot describe to see the minimum and then the maximum, right? So for the confirmed, for the death, and for the recovery. So from here you can see that we have our minimum as 44 for the confirmed, and then the maximum was this particular value. So this is the highest value, right, for our confirmed cases. So we'll be checking which particular country has the highest country. So that's the next question we're trying to solve. So let's call it as number of which country. We will check for the country later, but let's first of all check for, we have seen this is a maximum, right? Now let's check for the day, that particular day. So let's check for that particular day, right? So we want to check for that particular day that has the highest value this particular day. So let's go with df then per day, and I'll just go with my, using only the confirmed, right? Not the recovered. The confirmed usually is a combination of everything. So confirmed, then I can just go with max. If I go with max, it's going to give us the same result that we had here, right? So I go with max, so that is giving us the same result just as we had here. So if I go with min, it's also going to give us the same option for the minimum. So this is going to be the maximum number of cases. So it's going to be maximum mass number of cases, and then this is going to be the min number of cases, right? The same thing above, but I'm going to change this one to min, which is 44, right? So that is the basic idea, because that's the time it started. Now in case I want to get that particular date, right, to get the date, so let's go to this date of the highest, right? That particular date that we had this highest number. So date for maximum number of cases currently. So it's going to be the same thing that we did, but instead of using max, we're using IDX max, right? So IDX max is going to identify that particular date. So this is the date, which is actually the day before today, right? If you're watching from the future. So that is this particular date. So it has accumulated all the cases that's given us this particular date. So this is the date with the highest stuff. And then if you want to get the minimum, you can also do the same thing using the same thing of IDS mix. Let's check for that one. So this is going to be a lengthy tutorial because of we are doing everything from scratch. So this is going to be for the minimum, right? So it's going to check for the date for 44, which is going to be min, IDS min, which is the place that we started collecting our data. Very interesting. So that is how to get for the number of cases, the maximum number of cases per day, and the minimum number of cases per day, right? Cumulatively. Perfect. Now let's move on to the number of cases per country, right? So it's going to be number of cases per country or province. You just check for the country, you check for the province also. So let's try that one. So it's going to be df.group by, then I'll go with the particular column, which is going to be country dash region. So that is the group by country. Then I'll move on to the various stuff that we did. So just as we did here, we got the confirm, the deaths, and then the recovery or recovered. We can also do the same thing to check for the group of countries, right? The number of cases per country. Then I can just go with the same thing that I did, max. If I go with this, it's going to give us the maximum number. So these are the countries. So Afghanistan has only one confirmed case, Algeria has one, Australia has 8. So we are using the confirmed case, not the recovered. So out of the 8 people, only 4 recovered. Australia has 3. So that is something very interesting. So this is based on the country, right? So in case I also want to do the number of cases per country and then per province, I just come back to the same thing, and then let's make it like this. So I just pass in the province here. So you can just pass in the province first before the country. So let's call it as province slash states, right? I don't know whether it is province or state as we saw it. I think that is how we did it, state. So if I run it again, now so that now we have this particular province. So the province, the highest province is Anhui, Beijing. So these are the various values that you are getting. So China is having the highest confirmed number of cases, right? And out of these cases for China, we have this number recovered. That is a good news. So this thing, we can also actually plot this thing. So in case I want to plot it, we can also use several plots to help us with this. So let's try an example. Okay, so let's try that one. So that is the basic idea. So we have been able to see some basic stuff we can do. Now let's check on how to make some simple plots for what you have done so far. So I want to plot them by their country, right? So how do I do that? So I can just go with df by country. Then I'll just go with my country region, right? So in this case, I can actually use the value count to help me with that, right? So let's try that one. It's going to be dot value count. It's going to count all of them for us. So based on the region. So you see that China is having the highest from here, right? And I can actually plot this particular graph. So let's try a simple plot for this. So this is based on the value count, combining all of them, plot. Then I can just give it a kind of bar. Can be any plot that you want. Then I'll give it a figure size of 2010. So if I go with this is going to give us the value plot for all our countries, right, based on the number of cases available there. Perfect. So you see that China is mainland China is having the highest, followed by US, Australia, Canada, Philippines, right, as you can see from here. So that is something very interesting. So you're able to get some interesting stuff. Now let's check for how many countries have been affected. So this is going to be for how many countries affected. How many countries affected? See how I spelled many, Manu. Okay, so in case you have not subscribed to this channel, you can also subscribe to this channel and check the link below for some interesting materials to help you master machine learning and then Python. So let's go with the number of countries that have been affected. It's going to be country dot region underscore region. Then I can just go with the dot unique. If I go with dot unique, it's going to list all the unique countries there. So these are all the countries that have been affected. Then in case I want to count them, how many countries we have so far, so I just go with my stuff. Then I'll pass in length. So if I pass in length now, it's going to list it perfectly for us. So about 53 countries have been affected. Wow, that means it is spreading. Okay, so let's check some other stuff you can also do apart from these things. So we'll be trying to map them, right? We have gotten our details. We want to be able to map them on their continent. So how do we check for? We're checking for distribution on a map, right? On a map. So let's try that one. So we'll be using GeoPandas to help us with that. So before we move on to that, we can also do some interesting stuff with the value plot that we did, right? We did this particular value plot. This is nice, but in case I want to change it and make it, let's say, instead of bar plot, I want to make it pie chart, right? So I can just do the same thing here, but instead of using this particular option, I'll just take off this and I'll use the pie. So I go with pie, I'm passing my particular values, then it's going to automatically give us, so auto percentage, then I'll just pass in my values. It's going to be this particular stuff, right? So if I run it, it's going to analyze it perfectly for us and give us a very nice pie plot, right? So this is it. So let's make the size bigger because this size looks too small. So to make the size, we can just go to the top of our file, then just go with plt.figure, then I'll pass in my figure size of our famous figure size that we have been using so far, which is 2010, right? So if I run it, now it's going to be bigger for us. I have to do plt.show, but it's still going to work perfect. So this is our stuff here, right? So this is the distribution, mainland China, and then US, and then the rest, right? The rest of the country. Very, very nice plot. Now let's check for the distribution on the map. So we're trying to use something different to help us with that. So before we do to check for distribution on a map, so there are some stuff you have to do. First of all, we are supposed to get our latitude and then our longitude, right? Then we need to be able to convert them into geometry and then points, right? Geometric points to help us with that, right? To be able to map them very well. So let's see how to work with it. So we'll be using GeoPandas. So we already imported GeoPandas from above. So let's see what GeoPandas has to offer us. We imported GeoPandas as GPD, right? So I can actually check for all the various things that GeoPandas has to offer us. So GPD is going to give us our geodata frame, in which you can create a data frame to help us with that. You can also do geoseries and then several other aspects, right? Very interesting. Now let's see some various things that we can do about plotting for our map. So to plot for our map, first of all, let's convert our data to geodata frame. So how do we do that? So we're just going to call it as GDF01. There are several methods, but let's use the simplest method, GDF. This is going to be our GeoPandas. So GeoPandas dot geodata frame. So this geodata frame is coming from here, right? That's why I made us see this particular stuff. So we are using this geodata frame to convert our data into that particular format, into a format that you can actually use a map on, right? Then I'll pass in my data frame, then I'll pass in my geometry. So the geometry is going to be the points, right? As I said, that is the stuff we need. Then I'll move on from the geometry, then I'll go with my points point from S and Y, so SY. So this is a simple way. So this is the first method of trying to convert your data to that. Then I'll pass in my S and Y. So the S and Y is going to be my longitude, my latitude first. It's going to be my longitude, right? So the longitude is from our data set. If you can remember, I don't know, let's try to see it. Apologies for it being slow. Okay, if you can remember from our data set, we had it as the df, right, dot head. So you can see that we have our a column for that. See what I did? Okay, right, see that we had latitude and then longitude. So we're trying to convert this latitude and this longitude into a format that we can read with GeoPandas, right? So that's why we are passing that particular value here. So the longitude first, then the latitude. So that's going to be our df for our lat, right? These particular values here. So longitude and then latitude. Perfect. That is the basic idea, right? So this is the first method of converting it to GeoPandas. So it's giving us an error because points from, let's visit. Oh, see what I did? I forgot to bring it here. It's supposed to be GPD, right? Because if you check from what we did here, we learned that it had some various stuff and also have this particular function, right? So that is a function that you are using. So that's why we are supposed to bring it here so that you can see it very well. So perfect, it has converted it into a format that you can actually plot. If I come back here and I check it here, now it's a data frame, but it's, the type is a GeoPandas. If I check for the type of this my value, now it is a geo data frame, right? So that is the basic idea, and you can see from here that we have our geometries here. So this is the point that in case I want to plot on a map, it will be able to, it will going to use this particular plot to give us our nice plot, right? Very interesting. That is the first method of converting. There are several methods that can use. So the simplest method is what I showed you here, using the points from SY, right? But you can also use another method. So the next method that we can also use is, let's try that one. So let's call that method 2, right? So it's going to be method 2 in case you want to learn about it. So that is very simple. You can just call it as points. Then I'll just create a simple list comprehension of my points, right? Then I'll pass in my S and Y. So S and Y. Then I'll just use for S and Y in my zip, and I'll zip my longitude. So let's use dot long, and then df dot lat. So that is also, this simple code can enable us to do that. So I'm going to create a point. This is going to be our method 2. Create a point, going to list them perfectly together. Then I can actually put them in a geodata frame. So gdf02. Then I'll just pass in my value. So let's call that 02. Then I'll do the same thing above here, the same thing I did here, but instead of going with this particular option, I'll not go with the points from SY. It's going to be this option. So no need of this, right? It's the same thing. Now I'm going to pass in my value, which is going to be my points. And if I pass in that point, that is all, right? So it's going to work perfectly for us. So I can also view it. I call it 3 instead of 2. Anyway, it's still going to work, right? It's the same result. That is the second method of working with it. Now let's see how to actually plot it as a graph, right? Something very nice on a map, so that at least you see what you are doing, the reason you are doing all of this long stuff. So this is going to be our map plot. So first of all, it's simple. I'm going to plot it on a map. So the first thing is going to be geodf, our geodf1 dot plot. If I go with dot plot, and let's pass in a figure size of 2010. So it's going to plot the values for us, and you can see from it that I can see some distribution. So this is the distribution of the entire plot, right? So you can see that there are some here, there are some here, there are some here, but you cannot understand the coordinates. So these are the coordinates, right? But to be able to get the coordinate very well, you can also use, you can overlay it with a map. So let's call that one as overlap with world map, right? So we'll be trying to overlap it with our world map. So how do we do that? So first of all, let's import our world map. So it's going to be very simple. Let's call it as world. Then I'll pass in my values, which is going to be my GeoPandas dot read file. Then GeoPandas has its own data set that we can download. So we're going to go with GeoPandas dot dataset dot get path. So we'll be trying to get some natural path, right? So get path, then I'll pass in this particular stuff, which is going to be my natural. There are several of them, low res, right? So that's the basic idea. So you are trying to create or download or create a different map, world map from GeoPandas. So natural, low resolution, right? That's the basic idea. It's going to actually download it for us, and then it's going to create it perfectly for us. So I can just go with an access of my world plot dot plot. Then I can pass in my figure, our famous figure, which is going to be 2010. I don't know whether the voice, the audio is going off or small. Then I can just go with access dot access. Then I'll just go with off, right? So let's run it. Hopefully it's able to work without giving us any error. Perfect. Wow, so it's giving us a very nice plot of the entire planet, right? So this can be compared to this, but you want to overlap them together. So how do we overlap them together? So there are several ways you can do that. So the simplest method is that we're just going to be using this particular format. So we have the world map above. Now we want to overlap them. So this is going to be our overlap. It's going to be I'm going to create a figure, a variable called figure, another variable for the AS. Then I'm going to go with my matplotlib subplots. Then I'll pass in my figure size. So the figure size is going to be our famous 2010. Perfect. That is the first stuff. Then the next thing I'm going to do is that I'm going to be using or bringing my data frame. So GeoPandas data frame 01. You can name it as you want, and I'll bring my plot. So I'll be overlapping that particular plot. Then I can just give it a C map, a color map of C map, C map of my. I can use any value, so I can just go with purples. So all the colors here are usually plural. So reds, purples. Then I'll just pass in my axis. It's going to be my axis. Perfect. That's something very simple. Now I can just go with my world dot geometry dot boundary. So this is going to just give us only the boundary, not the entire stuff. So dot boundary. So world geometry dot boundary dot plot. Then I'll pass in my color. So I can just give it a color of none. So that it's going to use a default color. Then from here I can just give my edge color. So edge color is going to be K, right? So edge color. Then now I can just give it a line width of the particular value I want. Now pass in my axis. Let's go to axis. So that is something very big. So we are just creating, overlapping the plots together, right? That's something very basic. So let's plot it. So hopefully it doesn't give us any error. So it's going to work perfectly, and then you're going to see the difference, right, between this one and then this one, right? So if you check it back here, so now it has overlapped them very well. So this is a very nice plot. So you can see from here that China has a lot of them, and you can see that there's some in Egypt. I don't know whether it's Algeria. There's some in US. There's some in Brazil, some in Europe, and one in Russia, right? Something very big. So that is something very nice. So this is one way of working with it. So in case you don't want this particular boundary plot and you want to change the color, you can also do the same thing by coming back to here. Then let's change this color to, you change this from here. So just take out the boundary. Once I take out the boundary, I'll be able to put in any color that I want, right? So I can just put in a color like, let's say, yellow. If I put in yellow now, it's going to give us yellow and then with our plot there. But this is not going to be clear. This is more informative and more clearer than this one that is coming. So this is the same thing. So you can consider that you can't even see the colors, right? They are these small ones. You can't see it all. So the best one is to use this one, right? Very interesting. So that is something very nice. So now we are able to see how to overlap our colors together. Now let's see the next thing of trying to get our data individually and then see or zoom into them, right? Okay, so before we move on, let's try that one. So first of all, we're just going to get, this is going to be per country, right? You'll be trying to map them per countries, right? So first of all, let's check our values first. So if I go with my world dataset, so this is my world dataset. So this is it. So we have our continent, we have our name. So in case I want to select a particular continent, I can just come back to the same thing and go with my world, then continent, continent, right? Continent, that is the simplest way. Now, yeah, there are several continents there, but I want to be sure that the continent here is the same continent I know of, right? Not of what I think it is. Right, so let's use something simple of the world to bracket my continent dot unique. So this is going to list all of them for us. So these are all the continents that we have. So in case I want to check for Asia, I can just go with dash Asia. So I'm going to get all the continents for Asia, or the plots rather for Asia. It's going to be this, and let's put it inside a variable called Asia. Right, so this is going to be this option. Perfect. So now if I go back to Asia now, it's going to give us all the coordinates for Asia, right? Very interesting. So we consider these are all the coordinates for Asia. I can do the same thing for Africa, for the rest of the world. So let's try that one. So I just copy this one here, come back here, then change it from here, and then let's call this one as Africa. So this is going to be Africa. Then the next one is going to be for North America, and it's for US and Co. So North America. Then we just pass in here as North America. So North America, right? Perfect. Then we can also do for Europe. It's going to be the same thing that we did, but this time it's going to be Europe, right? It's going to be Europa. So Europe. Perfect. So we have been able to get the 3 continents. Perfect. Everything is working. Now let's see how to overlap them to actually see them. So we'll be checking each and every of them individually. So let's see how to work with that. So we'll be checking for only China. So let's check for cases in China. So to do that, it's just going to be, we had it like this, right? That is what we have. So in case I want to get all the cases in China, I'll be using the country region. It's going to be my df, my country region, country/region. Then I'll pass it as mainland China. So that is going to list only the mainland China for us. So I'll just go df again. So these are all the data points for China, right? Only China. Now I can actually use this one. Sorry, but I can actually use this one to map over it, to zoom in only on China. So how do I do that? So I'll come back to this same thing that we did, the same thing that we have here. Let's use the boundary one. I'll go with this, copy this one, so that we don't waste a lot of time, because we almost spending a lot of time here. Then I'll change this one here, right? So I'll be changing this one. So how do I do that? So I'll be using the geo data frame, not the normal data frame, right? So let's run this one again. So all the data have been converted to geo data frame. So I can actually do the same thing like gdf01. Then I'll check with the same thing here, the gdf01. Still going to give us the same result. Perfect. So I'll be using this particular one for our stuff. So this is going to be only for China, right? So I can just pass it here. This is a long format. Long format, right? And if I run it, it's going to overlap and then give us only China. So it's going to forget about all the other ones. So this is something very nice, right? So this is one way of doing it. So it ignored the rest, all the other points, and give it for only China for the rest of the world. But this is not what I want. I want to only get the continent of Asia. So let's try that one. So in that case, I just come back to this, and then let's run this one here in this particular format. So I'll change from world to Asia. So this Asia is referring to the variables we created. So this Asia here, right? So that's the same thing we are doing. So I'll just run it again. Then it's going to ignore the rest and give us only for Asia. So I think it's giving us overlap is not defined. the disadvantage of copying and pasting. So it's going to work perfectly for us. So voila. Perfect. So that it ignored all the other continents and give us for only Asia. Very, very interesting and very nice. So the same in case I also want to check for only India, can also do the same thing. So let's try for India. India is in Asia. So I just come back to the same thing. So instead of being mainland China, it's going to be India. And if I run it, it's going to bring only India for us. Perfect. So you see that India has only one. I'm surprised. China has more than India anyway. So let's try that one for another country. So we'll be trying for Africa. So let's go with Africa. And then this is going to be for Egypt, right? Because in Africa, it is only in Egypt and then Libya that it is reported that there is, right? So if I go with Africa, Egypt is going to print it perfectly for us as only one dot on Africa. Wow, only here. There's also one in Algeria anyway. So that is something very simple. I don't know whether it's Algeria. I think that is Morocco. I've forgotten. Okay, now let's try for US and then for Europe. So I'll just change this one from here to Europe, or let's go with North America. Then here we'll be changing the mainland to US, right? So if I go with this, now it's going to run it perfectly for us, identify the ones based on the region. You can see that we have it here. So these are the places that we have in US. Then let's try the last one for UK, for Europe. So this is going to be Europe, and then I can just go straight away to UK, United Kingdom, or Russia, any other country that is in Europe. And it's going to print that perfectly for us. So that is how it is. I think UK's own is very small. So that is the basic idea about how to overlap our dataset. Now let's see some other stuff you can also do, since our dataset also looks like a time series dataset. So let's try that one. So this is going to be our time series analysis. Some basic stuff, then you leave, right? Because time is going. So if I check my dataset here, you can notice that we have our dates here, this column. So that means that it is looking like a time series data. And then if you check for the day per day that we did, we also had something similar, the one that we grew by. So this is looking like more like a time series. So you can actually convert this particular stuff into a time series, or this one into a time series, and then see the trend. So now let's see how to do that. So first of all, I'm just going to store that one. Let's create a copy. So this is going to be a copy of our data set. It's going to be copy. Let's call it df2, then df, right? Perfect. So we can actually save our df.2 csv. So I can use it later on. It's going to be coronavirus data dot, see what I wrote, data clean.csv. Right, so we are saving that particular one. Okay, so let's see how to work with it. So first of all, we'll be trying to convert it into a format that you can work with time series. So there are several ways of doing it. So we'll be using time, so import date time as dt. You can just go without this. Pandas already has a date time format to help us with that. So I'm just going to go my df, and I'll just move on to the particular stuff I want to create. So let's call it as cases date. I create another variable, then I'll pass in my pd2 data date time. Then I'll pass in the column that I have that is with this particular column, right? You have our date column, so that's what I'm trying to work on. So I just pass in my date column. Then I can just leave it like that, or I can just put the format there. By default, it will identify all of these values that they are time and convert them perfectly for us. If I run it, perfect, so that has converted everything. So if I come back and I run it here again, let's do the df2 dot types. See what I wrote, .d type. Perfect. So now this is converted into a datetime format, which is the same as this one, right? So you can actually override it, but let's create a separate one for that. That is something very basic. Now we can actually work on it as a time series. So I can actually plot this simple that I've done using this option of what we did. So we had this. Let's do a simple plot of how our values goes. This is a bad plot anyway. So this dot plot figure size, then going to be 20, 10. So it's going to be rising. I see that it's rising up and down like that, right? So as the time goes, it keep on increasing. That is the trend based on the values that we have, right? So it keep on rising up and down. That's something very basic. There are several ways you can do that, right? So that is going to be an assignment for you. Now let's change it to all. Set that particular one as an index, and then do some TS. So let's go to TS for time series. Then I'm going to go with my df2 dot set index to my cases date. So now this is going to be a time series now. So I can actually do some interesting stuff. So if I come back and I run it here, then now this is better, right? So I can actually do some selection. So I can select which month, or for 1 month. So let's select for, let's say, January, right? So in case I want to select for only January, I can just go with my ts.ilog.log rather. Then I can just pass in the particular place. So it's going to be 20. So from here, you realize that we have it as it has been converted. So if I want to get only for January, I can just go with 2020. 2020 01, right? If I go with it, it's going to only select 2020, right? Leaving the rest, right? Very interesting, so that I can actually plot it in case I want to plot some various stuff. So that is one way. In case I want to select between January and then February, only for February, I can also do the same thing. In case I want to select between 2 months, like this date, let's select for, let's say, a simple date, let's say 24th, right? 2 days ago, and then the next one, so to be 2020-02 for this for February, just for just 1 day. So this is a value, so I can actually make a simple plot for this stuff. Let's try that one. So I just paste it here. So this is going to be for just 1 day, right? The previous day that you had. Then I'll go with my confirms, right? In case I want to plot for only confirm, I can also do that by coming back to the same place I have, and let's work on, let's say I want to check for only the confirm. I want to check for only the confirmed, and then let's say recovered, right? The cases that were confirmed and the cases that were recovered for this particular date, I can also do that. So let's place inside this option. So this is going to only pick that particular column for us. So these are the columns. Then I can actually plot this stuff out to see the trend, right? Because this is now a time series, so I can come back here, then go with dot plot, passing my figure size so that it becomes bigger a little. It's going to be 20, 10. Then it's going to plot perfectly for us. So by default, it's going to use line, so that now it's, you can see it very well. It is very, very thin, right? It's almost the same. That is when you are comparing the recovered and then the confirmed. That means that there is a very low level of recovery, right? So you can also try, if you check from even our data set here, see that these are the number of people who are recovered. There are less people recovering than people who are being confirmed to have it. But I can also check for the death by coming here. Let's add death to it. So this, you can also plot for death. Deaths is plural. Then it's going to give us a plot. So you can see that from here it is very little. The blue line, as you can see from here, is the confirmed, and then the green, the purple, or is it orange? I think it's orange. It's the death, right? So that is something very big. So this is just for just 2 days, right? For this particular simple date. So in case I want to be more specific or be more strict, I can give it 1 day. So let's give it the same day, and let's see. Hopefully it's able to give us some data. See, there is no data there. I think there's very less data. That's why it's given at this particular plot. That's something very basic that you can do. So there are several things you can do. So the power is in your hands. So I hope you have learned something. So the basic idea of what that we did was that we're trying to analyze our data set to see the correlation between them, and then some various interesting stuff you can do. So thank you for watching. So in case you have any question or contribution, you can just put inside the comment section below, and I'll link the links and the articles and all of those things so that you can actually check them and then work on them and do some interesting analysis with them. So thank you, and then see you in the next session. Stay blessed. Bye. Oh, one more thing. Let's do a little plot before we go. So using the dates per, right? I think it was this. I don't know whether it was there. I think it was this. Right, so this is something very simple. In case I want to actually do a simple plot, I can also do that plot by that. So let's make it in a different way. So let's call this df by date. Then I'll pass in my ts dot group by. You can also use the group by on the time series. So group by. I'll pass in my cases, dates, dates. Then I can just go with dot sum. If I go with dot sum, now it's going to list it perfectly for us in a different format. Then I can actually reset it. So let's go with reset dot reset index. Then I'm going to be dropping it. So drop equal to none, right? So let's work on it. So we have gotten a different data frame that we can actually do a simple plot, which is some interesting, nice plot. So that is it. Now we can actually do a simple plot to see the correlation between the day and then the confirms, right? So we can just do a simple plot here. Let's do that last plot and go. Although we have already closed. The df by date dot columns. Then I can just go with this option. So I'll just copy this one, and then we can just plot that one out. So we can give a simple plot for that. So it's going to be df by date, passing this particular value that we have, and I can just do a simple plot to see the trend, right? So dot plot, the kind is equal to bar, or it can be line, anyhow. Then let's give it a figure size of 2010. So this is going to plot some very simple plots for us. So this is confirmed, depth, and recovery, and you can see that as time goes on, the confirmed is increasing over time, but the depth is also going down, and then the recovery is going. So that means that they are making progress on the coronavirus. There are some interesting benefits or interesting means they are using to manage the disease. So thank you for watching, and see you another time. Stay blessed. Bye.